In this video, we are going to take a very traditional word problem where we're given some very specific details, and we are asked to create a linear model for those details. So some background information. First off, we need to know what is a linear model. Well, the word model could be replaced with the word equation. So we're to be creating a linear equation. And so a linear equation always has the format y equals mx plus b. So that is what I'm supposed to create. In the y equals mx plus b equation, y will be a variable and x will be a variable. We'll want to define what we're using as those variables. Let's take a look at our word problem. A real estate agency has fixed monthly costs associated with rent, staff, salaries, utilities, and supplies. It earns its money by taking a percentage commission on total real estate sales. During the month of July, the agency had a total sales of $832,000, showed a net income after paying fixed costs of $15,704. In August, total sales were $326,000 with a net income of $532. So what I want to do is I have a pair of numbers for July and a pair of numbers for August. And pairs of numbers can be ordered pairs in algebra. I have to think about my XY ordered pairs that the X value should come first, logically. So when I think about real estate, they need to sell a piece of land, a home, something, and then they will have income. So they have to sell something first before they have income. So for July, I see my ordered pair as $832,000, which is the amount of sales, and I'm pairing that with an income of $15,704. And then in August, I want to make a similar pair. So I see sales of $326,000 and I see income of $532. Now, in doing this, I see that X was my sales. So up here in my formula, I'm using X for the sales, real estate sales, and I'm using Y for the income. So I can define those two variables. Now, I know that M is slope, and I know that B can have different meanings. It can be the y-intercept, or the starting value. They do not give me a starting value. So although that is useful in some scenarios, that definition is not useful here. So let's see what we can figure out. Well, since I have two ordered pairs from reading the question, I am going to use them to calculate slope. So I know that M, the slope, is found by subtracting the y values, the change in y, over the change in x. And so taking my ordered pairs, my y2 is 532 minus my y1 is 15,704, using the same pattern, so 326,000 minus 832,000, and I go ahead and do my math on all that. So I have negative 15,174, excuse me, 15,172 divided by a negative 506,000. And I'm going to divide that out, and I rounded it off to two decimal places, so 0.03. And so now in my equation, what I know is I know that y equals 0.03x plus b. But to finish out the model, I also have to know an actual value for b. In order to solve for b, I'm going to use an ordered pair for x and y. I decided to use the second ordered pair because the numbers were a little bit smaller. So for y, I have 532, and that is equal to 0.03 times 326,000, filling that in for the x, plus b. So the first thing I did is I did the multiplication, so that gave me 532 is equal to 9,780 plus b. And then I subtracted from both sides, and so b was 532 minus 9,780, which gave me a negative 9,248. And this allows me to give my formula. So with my formula, I will have y equals slope of 0.03 x minus 9,248. And so this is my answer. And so what I have done is I have created a linear model, which is a y equals mx plus b equation based on the numbers that they gave me.